So, I am going to discuss about general organic chemistry. So, in this chapter, we will be going to know intermediates and stability of the intermediates. So, at first, I want to inform you something that reactants does not form product directly. At first, they form an intermediate. Then they form a product. That's why here you can see that reactant comes first, then intermediate, then product. So now comes to the intermediate part. So here you can see that these are the intermediate that we have to know. That is carbocation, carbene, free radical, carbene, benzene, nitrene. Now carbene has two parts. Number one singlet and number two triplet. Now next come to the carbocation part. So here you can see that this is the image of this carbocation. Okay, it's a ethyl carbocation. Now comes to the characterization of the carbocation. It is sp2 hybridized, triangular planar, electron deficient, that is electrophile, that is electron lover. These are the examples that you can see: propyl carbocation, benzyl carbocation, isopropyl carbocation, and then stability of the carbocation. So on the basis of these four things, you always determine the stability of carbocation. A, aromaticity, R, resonance, H, hyperconjugation, I, inductive effect. You always remember this stability part as a simple word, that is RAHI. A means aromaticity, R means resonance, and H means inductive effect. H means hyperconjugation, I means inductive effect. Now let's come to the carbanion. So here you can see the carbanion part. Okay. So here you can see a lone pair is there, and it looks like a pyramidal structure. And this is a sp3 hybridized, as you see in the characterization part. It's octet completed, electron rich species, nucleophile, that is it can donate electron pair to electrophile, sp3 hybridization as total pair 4, pyramidal structure, diamagnetic as no unpaired electron, example propyl carbanion, isopropyl carbanion. Then comes to the next part, stability of carbanion. Here you can see on the basis of same things, we always determine the stability of carbanion. But here one thing that I want to inform you, that hyperconjugation case is very rare. That is, in some very rare cases we always we find hyperconjugation part. Okay, most of the cases we always determine stability of carbanion, aromaticity, resonance, and inductive effect. Okay, so now comes to the free radical part. So here you can see the free radical. It's a healthy free radical. Then after releasing one electron, it is converted into a free radical. Healthy electron to comes out, and free radical is formed. Here you can see that in this picture. Now introduction, how this free radical formed. So when two atoms having very less electronegativity difference are bonded by a sigma covalent bond, the bond get a tendency for homolytic fission in presence of external effects. The effects are heat, light, that is UV ray, electricity, peroxide, and radical initiator. Then free radical is formed. Then comes to the rest of the free radical part, that is free radical can combine to form neutral species. Free radical starts chain reaction first. It occurs in three steps, that is chain reaction, chain prolongation, chain termination. Then you can see here the characterization of free radical is odd electron species, for example 7 electron species, electron deficient species, that is electrophile, that is electron lover. In case of any free radical step, the hybridization is sp2, and in case of any trihalomethyl free radical, hybridization is sp3, as here is unpaired electron. It's paramagnetic, unstable, very short lived, that is 10 to the power minus 6. Now then comes to the stability of free radical. On the basis of same things, we always determine the free radical similar to carbocation. At first aromaticity you have to check, then resonance, then hyperconjugation, then inductive effect. Then comes to the next part, carbene. So here you can see the carbene. It's a triplet carbene and it's a singlet carbene. Okay. So now comes to the characterization part. Here, carbene is very unstable, good electrophile, very reactive, neutral, no charge, carries carbene is two types, that is singlet and triplet. In singlet, diamagnetic it is, and stable in aqueous solution. 8 kilocalorie higher energy and lower stability. Triplet stable in a gaseous state and 8 kilocalorie per mole, lesser energy and higher stability. Stability order, that is singlet is less stable than triplet. Here you can see in characterization part, as bond angle is 180 degree, that is more open structure and space. So these are the things that I want to share with you guys. Now, if you like this channel, please like and subscribe this channel. Okay, thank you.